Follow the trick I am using. First, I multiply real into real and imaginary into imaginary. Then real into imaginary like this. 3 into minus 3i minus 9i minus 6i. That means finally 15i. Thus we have got two equations. X square minus y square equal to 1. 2xy is equal to 1. We have to find the values of x and y. Next I work out another sum, very simple sum. Actually I have not worked out sums on modulus amplitude many, that is why I am work out one more. If z equal to 2 minus 3i to express 1 minus 2z by z minus 3 in the form a plus ib. Then we shall find its modulus amplitude. Very simple one. Just we need to simplify this one. 1 minus 2z by z minus 3. Putting the value of z, we first simplify. 1 minus 2 into 2 minus 3i divided by 2 minus 3i minus 3. 1 minus 2z by z minus 3 given z equal to 2 minus 3i. Let us simplify. 1 minus 4 plus 6i by minus 1 minus 3i, that is equal to minus 3 plus 6i by minus 1 minus 3i. We first multiply by minus 1, 3 minus 6i by 1 plus 3i. Now we multiply by the complex conjugate of the denominator. Here complex conjugate will be 1 minus 3i. Now the product of the numerators and denominators, 3 plus 18i square means minus 18 minus 6i minus 9i. Follow the trick I am using. First I multiply real into real and imaginary into imaginary. Then real into imaginary like this. 3 into minus 3i minus 9i minus 6i. That means finally 15i. And this one 1 minus 9i square. That means plus 9 3i minus 3i into minus 3i into 1 3i and 1 into minus 3i minus 3i. 3i minus 3i. Finally, minus 15i divided by 10. Dividing both numerator and denominator by 5, we get minus 3 minus 3i by 2 minus 3 by 2 minus 3 by 2 I. I write final form like this: 1 minus 2z by z minus 3 is equal to minus 3 by 2 minus 3 by 2 into I. This is of the form which is of the form a plus ib. Here a equal to minus 3 by 2, b equal to minus 3 by 2. Thus, we have solved the first part. Then we have to find its modulus and amplitude. Therefore, modulus of this complex number is equal to 9 by 4 plus 9 by 4. That means root over 9 by 2 that will be 3 by root 2. 3 by root 2, that is the modulus. You can express that rationalizing the denominator. That means you can write 3 root 2 by 2. Now to find the amplitude. R cos theta equal to minus 3 by 2, R sin theta equal to minus 3 by 2. I discussed earlier, when you are going to find the modulus and amplitude, especially for amplitude, you write the polar form of the given complex number. That is r cos theta plus I r sin theta is equal to a plus ib. Here a is equal to minus 3 by 2. Therefore r cos theta equal to minus 3 by 2. R sin theta equal to minus 3 by 2. Also, one thing, first you locate the position of the complex number in the z plane or complex plane. Here both negative, a, b both negative. That means z is lying in the third quadrant. Both negative, that is to be kept in mind. Now we divide this one by this, then we get tan theta equal to minus 3 by 2 minus 3 by 2, that is equal to 1. But that is equal to tan pi by 4. I write like this. Since minus 3 by 2 minus 3 by 2. Note this one lies in the third quadrant in the z plane. Therefore, theta will be equal to, already I have mentioned that in that case you have to apply that concept minus pi plus theta. Minus pi plus pi by 4. Since the point lies below the x-axis, we have to express the amplitude in that form. Therefore, after simplification, it will be minus 3 pi by 4. Therefore, amplitude of the complex number is equal to minus 3 pi by 4. Actually, I worked out such type of problems earlier in the initial stage. I have now solved one sum for you. Next thing that is to be mentioned, that the last thing of this topic, I would like to mention that when the square root of a given complex number is to be found out, generally in many cases we get that square root or square roots by method of inspection or trial method. But in few cases we are to apply theoretical approach. I take one sum to explain that, to find the square root of one plus I. The solution will be like this. Let according to the properties already discussed earlier, square root or any root of a complex number will be itself a complex number. Following that concept, I have taken square root of 1 plus I is equal to x plus iy, then squaring 1 plus I is equal to x plus iy whole square, or write this expression on the left, x square minus y square plus 2ixy is equal to 1 plus I, equating real and imaginary parts. X square minus y square equal to 1, 2xy is equal to 1. Thus we have got two equations, x square minus y square equal to 1, 2xy is equal to 1. We have to find the values of x and y. Here you see solving such type of equations I have not discussed yet. Generally we use three ways. After getting, we find the value of x square plus y square, applying the identity learned in lower classes, or we find from this equation generally y in terms of x or x in terms of y, and put that value in the first, and we will get equation involving x. I follow the first one. Call this 1 and 2. Now x square plus y square whole square, a plus b whole square. The identity is a minus b whole square plus 4 x square y square. Put the value. This is 1 plus 2xy whole square, that is 1 plus 1. Therefore, x square plus y square is equal to, this is 2. The value will be plus minus root 2. We are taking root 2. Actually, while we write the answer of square root, we put plus minus symbol. Therefore, for solving purpose, I have taken plus root 2. Now, x square minus y square equal to 1 and x square plus y square is equal to root 2, that is number 3. Now, 1 plus 3, adding these two equations, what we get? Y square cancelled, therefore 2x square is equal to root 2 plus 1. Therefore, x square equal to root 2 plus 1 divided by 2. Therefore, x is equal to plus minus root over root 2 plus 1 by 2. See this. Value of x is quite complicated. Now, putting that x square in the first equation, we shall get the value of y square. Putting y square, putting in 1, putting this value of x square in 1, root 2 plus 1 by 2 minus y square equal to 1, or y square equal to root 2 plus 1 by 2 minus 1 root 2 minus 1 by 2. Follow that. Therefore, y will be equal to plus minus root over root 2 minus 1 by 2. Another thing I mention here, x square plus y square, x, y are real, therefore sum of two squares cannot be negative. That is why minus root 2 is to be rejected. Note this one, x square plus y square, that means sum of two positive numbers or non-negative numbers, that cannot be negative. That is why minus sign is rejected here. Thus, we have got the values of x and y. Therefore, required square roots. Thus, in some cases, we can't use the method of inspection or trial method. In that case, we have to solve such type of sums in this way. Thus, I have discussed related matters of complex number in detail. All theorems, all results, and different types of sums. For students, this is my tips or my suggestion that you read from your book carefully, also notes or matters given by your teacher, and if you follow such type of online classes, follow thoroughly, then see all the examples in your book, then you try to work out sums in your book or in your textbook. Thank you.